Hi everyone, welcome to the 26th episode of the Coffee with Cosmos DB series. If you have missed to join the stream last time, you can watch the recording under the playlist. Also, if you're interested to present in this channel, please submit your talk via the link displayed below the description of this video. If you would like to know more about a particular topic or a feature, please ask in the chat so that we can take it up and discuss here. As you know, this series is all about spreading the knowledge on Cosmos DB by the experts to the community. So please make sure to subscribe the channel and share with the community members who are looking to learn more about Cosmos DB. With that, let me introduce our guest for today. Hi, Felicia.
Hi, Saji. How are you doing?
How's it going? Yeah, doing
Very
well.
well, thank you.
Yeah, today we have an interesting guest from the Azure Global Black Belt team. Please introduce yourself to the audience, Felicia.
Yeah, thanks, Saji. Thanks for having me. So, hello, everyone. I'm Felicia. I'm Cosmos DB specialist, and today we'll be illustrating how Cosmos DB is an excellent backend for modern applications. So, I'm going to share my screen.
Yep.
So this is the agenda for today. We'll first analyze the requirements of modern applications, which are the applications our customers are currently thinking about and implementing. Then we'll provide a high-level overview of vector search, which is a feature that can really augment your operational use cases, and how we do this with Cosmos DB. Then we'll see how Cosmos DB is an excellent background for these modern applications, thanks to its always-on, low latency features, capabilities, as well as native vector search, which combined with other services such as Azure Open AI can enable conversational use cases over your operational data, which is very interesting. And then we'll showcase it all with a demo. So I believe we've been talking about modern applications for a long time now. Like ever since big data was born, we've been talking about this. But now there are a couple of things that are different. Like one of them is generative AI, which has totally changed the way we interact with our applications, and the possibilities are immense. And then the other thing is that it's really, really easy to implement smart applications with Azure, like very easy. So modern applications, what do end users expect? From an end user's perspective, they want the applications to be always on. They want personalized interactions, and they want real-time, like immediacy, right? In order to be able to innovate, we need to use different and diverse sources of data. We need to use machine learning, AI. We want the applications to be able to continuously learn, use natural language, scale with demand, and enable real-time business intelligence. Why not? And then from a cost perspective, the applications have to be fast to develop, so the time to market has to be short. We need the applications to contribute to increasingly automate our business processes, and we want the applications to be to reduce the operational cost, not only in terms of cloud services, but also in terms of maintenance, right? And we want them to be able to evolve, be flexible, and respond to changing business needs. So in Azure, we have the right suite of services to implement this kind of applications. Of course, we have all the containers and the Azure Open AI, but today we're focusing on Cosmos DB. There are other databases that we can use, but today we're focusing on Cosmos DB. So imagine classic operational use cases, like classic, okay? Operation use cases that you can implement with Cosmos. So for example, in any industry, you can think of using Cosmos DB as a backend to implement your shopping cart use case or product catalog. You serve it from there, from Cosmos. E-commerce, inventory management. For example, if we're talking about financial services or insurance, you have open banking, or you have categorization of transactions. You can store any kind of report, police, medical reports, You can do lots of things with Cosmos DB as a backend. In manufacturing and logistics, of course, we have all the IoT, so the measurements and the management of the devices. And as soon as you have an end user here in these two on the left, well, you can think of use cases such as customer view 360, or you can store claims, you can store your profile for your user, so you can serve these and integrate them with business applications. You can also store any kind of correspondence. But in the end, like Cosmos is an excellent backend for web apps, for mobile applications. You can use it as a fast cache. But what if you could augment these classic operation use cases with Azure Open AI? In that case, you would have, this is the same slide, but augmented. So you could think of allowing the navigation of your product catalog in a conversational manner, which makes it a lot more fun. You can enable the classification, for example, of your reports, assistance with the writing, analyzing your claims. There's a bunch of things that you can do. And also you can do similarity search, which is what we're going to go through later today. So the possibilities are many. So, for example, what can we do with application services, AI services, and Cosmos DB? For example, you can use historical data to serve very relevant information to your end users. You can enable that in real time, timely. You can scale with demand, thanks to the elasticity. You can enable search, vector search, which we will see. Also, text search, hybrid search. You can increase the impact of your applications by providing highly personalized content, and you can also enable conversational use cases, which makes it like more human and more fun in the end. So, what is vector search anyway? So imagine this is a high-level overview of vector search. Okay, imagine this is your data. Now you can describe your data as a vector, like you can place it in a Euclidean space. In this case, I've chosen a 3-dimensional space for the sake of clarity. But in general, vectors can have thousands of coordinates. These coordinates you describe your data with are called embeddings, okay? So now you have your data placed in a Euclidean space. What you can do now is to do similarity search, which is vector search. So for example, you have an input, you can vectorize your input, and now you can compare with the data that you have, the vectors that describe your data, and you can provide the most relevant content, so the closest to the one you're looking for. And how do you do that? Well, you do that with math. You can compare the distance, measure the distance between vectors, for example, by using the cosine of the angles that they form, okay? Or this is just math. So what do you do? What do you use this for? Well, if you have vector search, what you can do is compare data very quickly. And you can do this not only with text, but you can also do it with images, any kind of data, okay, that you can annotate. If you have text, you can think of conversational search, creation of synonyms, Q&A kind of applications. And most importantly, you don't have to type the root of something, the root of the word you're looking for. Like, for example, kitten, kitty, and cat is the same. It's not the same, but it's very similar, right? And you can also do that with other kinds of unstructured data. So that would enable to find similar content among your data or just browse your unstructured data. So it's very powerful. And how do you do this in Azure? Like, the first thing you have to do is to create the embeddings for your data set. Now, the embeddings, you can create them with a machine learning model that you have, or you can use Azure Open AI. So you request the embeddings, and then what you do is you store those embeddings along with the operational data that you have in Cosmos DB, and you create an index so that you can search. But this is important because you're using the same operational database that you're using for your common use cases. That's where you're storing your vectors. So you don't need anything else. And then you can search by proximity, which is actually the vector search. And with Cosmos DB, we have different options in Azure to do this. Like the first thing we have to do, as I say, is to generate the embeddings, and then we have different flavors in Azure to do this. The first one would be to use Cosmos DB from MongoDB vCore, which supports this feature in a native manner. So you can create the index in the same database, and everything is native, and it's very easy. So the architecture is very, very, very easy. You can do this with any other RU-based API in Cosmos DB as well. So you can store the vectors, but in this case, the creation of the index has to be external. So you have to use Azure AI search to create the index and search. It's going to be native in Cosmos DB for NoSQL like very soon, like very, very soon. The third option would be to use Cosmos DB for Postgres. So you know that this distributed Postgres, which is the old Citus, has now been included in the Cosmos DB portfolio, and it also supports native vector search. And the final option with Cosmos DB would be to use Cassandra Managed Instance, which also belongs to the offering of Cosmos. And in this case, it's also native, but it's in preview, okay? So with any of these options, we could vectorize an input, we could do the search, and we would provide the vectors back. Of course, we don't provide the vectors back to the end user because it could be like 100 vectors. We wrap them nicely in a sentence, okay, using Azure Open AI. It's what is called completions, and we'll see this later as well. So why is Cosmos DB a good backend for this kind of applications? Well, first of all, I'd like to mention that Cosmos DB is a foundational service in Azure. This means that it's present in every single region across the globe. And the reason for this is because there are lots of Microsoft applications that run on Cosmos DB. For example, Teams. For example, ChatGPT stores everything in Cosmos DB, LinkedIn. So that's why. And this gives you an idea of how well it scales. When do you think of Cosmos DB as a backend in general? So for example, if you need to scale, if you need low latency, if you need high availability, any yes to these questions can make you think of Cosmos DB as a good fit. If you need geo-replication across different regions, because that's something that Cosmos DB can do. If you have an evolving data model, or if you have the same business entity, which is represented with different data models. For example, in multi-brand, you have two bills and they are different, or in IoT, this happens a lot because you have different vendors and the information is more or less the same, but it's always represented in a different way. If you have event-driven architectures, microservices, or if you want to empower your operational use cases with Azure Open AI. In any of these situations, Cosmos DB can be a very good fit. Now, Cosmos DB is a fully managed database. It's fully managed by Azure, so you don't need to worry about the nodes. It's distributed, but you don't have to handle that. Cosmos DB does it. You can geo-replicate your data across different regions if you need to. It's not compulsory, but it's an option for you so that you can take your data close to the user, so close to where it's going to be used. It's very flexible because it contains, it provides different operation modes to serve different kinds of workloads, like very steady workloads or very spiky. It depends. You have different consistency models. So this is for when you do multi-region, how you propagate the data across different regions and when you serve the data. And then you have the APIs that are based on JSON. You have the flexibility of JSON, of course. It's very versatile because you have different APIs. So you can use Cosmos with the core API, which is the NoSQL API. You can use it with the Postgres API, and then you can use it as if it were other technologies, for example, Mongo. It's scalable, so it's made to scale. It pops nodes as required when size or throughput require it. It's got a very impressive, comprehensive suite of SLAs, not only the availability of 5 nines, but also a latency SLA for the NoSQL API, and also the throughput is guaranteed. So you you specify which capacity you want the database to give you, and it will give you that capacity with an SLA. Also, the consistency models are ensured with an SLA. And yeah, and the throughput, yes. So it's compatible with many services in Azure. Of course, Cosmos DB is not a standalone piece. Like, it belongs in a higher level architecture where you can build end-to-end solutions that provide value to business processes. So yeah, and finally, you can enable near real-time analytics over your operational data with no ATL and without having an impact on your operation, thanks to the analytical store and now the integration with Fabric. So why is Cosmos DB good for AI? Well, the first reason, the most immediate reason is because you can store the slide is advancing. You can store your machine learning results and serve them, integrate them with your business processes. You can also do vector search. So within the same database you're already using, you can store the vectors. You can enable conversational data. Sorry about this. The slide is advancing. So Cosmos DB stores a JSON, and Azure Open AI provides a JSON. So it's very straightforward. Another advantage is you can scale with your application demand. You can provide the low latency and the throughput. And finally, you can also persist your data. So the conversations, you can persist them. Oh my God. You can persist them in Cosmos DB. So this provides context to your bot. You can provide, in the end, summarization analysis. You can know what's going on, classification of your conversations. And also, finally, it can also help with the reduction of cost for Azure Open AI for several reasons. Because you can use it as a cache for your conversations. Because you can restrict the prompt generation to the results of a previous vector search. So you reduce the number of tokens that you have to use. And because you can just, instead of retraining the whole model when your data changes, you can recalculate the embeddings in Cosmos DB. So those are the main advantages, I'd say. And now I'm going to show you a demo of
Felicia, sorry to interrupt.
Yes.
There are a few questions on the chat. Probably
yes,
I will
of course.
read out them. The first question is regarding the offerings that you shared. I mean, how each of those vector search offerings are different from each other.
Sorry, what is the question
MongoDB
again?
vCore.
Yeah. So
in the second slide, I guess you shared different offerings on the vector search,
so
right?
Cosmos DB has different here. Cosmos DB has different APIs. So you have the NoSQL API, which is the core Cosmos technology, and then you have Postgres, which is distributed Postgres. So it belongs to the same offering, Cosmos DB, and then the NoSQL API is the core one, but you can also use Cosmos DB as if it were other technologies. For example, you can use it.
I guess the question is more about. Sorry to interrupt.
Yes.
The question is more about the vector search offerings that you showed earlier on Postgres, on MongoDB vCore. So how each of those? Yeah, that's right. Yeah.
Okay, so the difference between these are that when vector search is native, the architecture is very easy because you can provide the indexes within the same database. Now, with the RU-based flavors of Cosmos, you need to use Azure AI Search on top of Cosmos to store and to create the indexes. Okay, that's the only difference. Cassandra Managed Instance, it's Apache Cassandra managed in Azure. And it also provides this feature, but it's in preview for the moment. Does this answer the question?
Thanks. Yep. Yeah, I guess so. The other question that I see on the chat is how are the embeddings values are created? Does it use OpenAI embeddings API?
Yeah, exactly. You can use the embeddings, so the model that Azure Open AI provides, or if you have your own embeddings model, you can use your own. But I mean, it's so easy to use Azure Open AI to create the embeddings. Very, very easy.
Got it.
I'm gonna show that in the architecture of the demo. I'm gonna.
All right.
Any more
There
questions?
is another question as well. Yeah, what is the storage limit up to which we can do vector search with Cosmos DB?
Oof, that's a very specific question. I think I'll look for that and post it in the chat if possible.
Yep. Okay, that works. Yeah, those are the questions on the chat. You can proceed with the demo.
Okay. So what I want to show you is, so this is the classic architecture for a conversational application with Cosmos DB from MongoDB vCore. So the first thing is to store your data set in Cosmos, MongoDB vCore, for example. Now, what you do is you implement a function that invokes Azure Open AI to create the embedding. So you vectorize your data. This is what you do. And once you have the vectors, what you do is you store them back with your operational data in Cosmos DB. This is a cool advantage that you can use the same operational database for everything. And then you can enable a web application, which is going to be used by end users to search something. But the search has to be also, so the input has to be also vectorized. So we can request the embeddings for the input. And that's when we can do vector search, because we can compare vectors to vectors. And of course, we compose an answer. We don't provide the vector straight away. We provide a nice answer, and this is what we give to the end user. And in the end, what we can also do is persist everything, the whole conversation in Cosmos DB for later analysis, to classify, to see what's been, and to provide context, as I was saying before. So I'd like to show you an application that is exactly doing this with Cosmos DB for MongoDB vCore. So it's a retail use case. So I've got lots of, it's a catalog of bicycles, okay? And so we can create a new chat and ask, the data has already been loaded in Cosmos DB and it has been vectorized. So I can now just query my data. So I'm gonna text, for example, I'd like to buy a yellow bike. And it's going to give me options. What do I want, a road or a touring bike? So what is the difference between a road bike and a touring bike? And it's going to the catalog and it's extracting the information from there and then it's wrapping it in a nice conversation. So it tells me the difference between the two kinds of bikes. And now what I wanted to do is please list yellow touring bikes and their prices. And these are the options, okay? So that's one application that I wanted to show you. And the second one is here. So this is, these are cooking recipes, okay, that we have uploaded up to Cosmos and we have vectorized. So what I want to show you is how this can really, really augment your operational data, because I'm going to ask for a recipe. I'd like to cook paella. I have added to the data set a couple of Spanish recipes. And what's going to do, it's going to tell, it knows that the recipe for the paella that I added was a joke, because I said paella is a very difficult dish, in my opinion. So I said, forget about cooking paella, call a local dish delivery services. So it really interprets it's a joke, which is super powerful. And then, of course, you can you can configure it to be more creative or less. So you have options there. And the second thing I'd like to show you how it can really enhance your operational data is I want to, I'd like to cook salmorejo, which is a cold soup, tomato soup, okay, with garlic. And so I'm gonna ask the recipe for salmorejo, and this is the here on the top. At the top, these are the ingredients and these are the instructions. And I have added salt in the instructions, but I have forgotten the salt in the ingredients. And thanks to Azure Open AI, using the same recipe, it gives me the salt and the cured ham and boiled egg. So it's really enhancing your data, which is super powerful in my opinion. So that's all I had for you. I don't know if you have more questions.
Yeah, thanks. Thanks for the demo. It was awesome. There is one other question.
Yes.
I think this is related, and probably you might have already explained. Can the embeddings be created automatically when the data is inserted into Cosmos DB?
I think you can create the embeddings automatically when, for example, when you use Cosmos DB for NoSQL, and you can use the change feed feature, which is a feature that is able to detect changes on the data. So if you use the change feed, you can program it so it starts from the beginning, and then it will invoke the function, because you can configure it. With MongoDB for vCore, I don't think so. What you do is usually as you load the data in the same process, you go and request the embedding. So you store the data together with the embeddings.
Got it. Thanks. Yeah, those are the questions we had from the audience. Yeah, please feel free to post your questions if you have anything else to discuss or ask. I have a question from my side.
Yes.
How is native vector search different from Azure Search that we have?
Yeah, that's a very good question as well. So I'd say if you're already using Cosmos DB or you are thinking about using Cosmos DB, you know that you can use vector search to implement this kind of use cases. The architecture is very simple, and of course you have all the low latency throughput, guaranteed throughput, the features, the advantages of your application, everything that Cosmos DB brings along. Now, if you want to do search across different data sources, that there you would use AI search, combining different sources. Or if you want to filter some fields, for example, that is not supported in Cosmos DB yet. It's going to be very soon, but not yet. Or for example, if you need like a more sophisticated kind of search, like hybrid search, things like that, in that case, you would use AI, Azure AI search.
Got it. Thanks a lot. There is one more question from the audience.
Yeah.
One beginner query: why use Cosmos DB for vector search instead of cognitive search? I think that's what you already explained.
Well, basically, yeah, because if you're already using Cosmos DB, the architecture is so simple, you don't need anything else. But as I say, if you need more sources or more sophisticated features, then you should use AI search, which is cognitive search. It's a new name.
Yeah, I think there is a follow-up question as well. With Cosmos DB, your data is with your vector data as opposed to have separate. Yeah, that understanding is correct. All right, I think we answered most of the questions. And yeah, if you have further questions, please post them as comment on the video. And thanks a lot, Felicia, for your time and also sharing your insights with the audience and answering questions. Yeah, we will catch up again in a couple of weeks with another special guest with another topic. Yeah, thanks again for joining. Have a good day.
Thank you. Thank you. Bye, everyone.